Hello, everyone, and welcome to this week's interview. My name is Ellen Rankins, and I am a PhD student here at the Equine Science Center at Rutgers University. And with me today, I have Dr. Dylan Klein, who is an assistant professor at Rowan University. So welcome, Dr. Klein. We're glad to have you on with us.
Hi, Ellen. Thank you. Glad to be here.
So to get started, I'd like you to share a fun fact about yourself so our listeners can get to know you a little bit better.
Um, Usually my fun fact is that I worked with horses for my PhD research. But in addition to that, I guess a fun fact about me is that I'm an avid dog lover. I have a 7-year-old pit bull lady who's actually right beside me right now. Ever since a little kid, I've always really loved animals. And actually, now that I think of it, a not only fun but I guess ironic fact is that my best friend growing up, he and his family, they owned, bred and raced thoroughbred horses. So I'd been around horses and horse farms and the racetracks since I was at a very young age. However, I really had never touched a horse until I came to Rutgers to do my PhD. So there's two fun facts for you, actually.
Well, thank you for sharing. That's very cool. And I guess your research here then was just meant to be.
Yeah, you could say that for sure.
So I wanted to start out with kind of backing up a little bit and asking about what motivated you to pursue a PhD in the first place.
Um, so, kind of before this, we talked a little bit about my background. I did my undergrad at Rutgers as well. It was in dietetics. And I thought I wanted to be a sports dietitian because I've been an athlete my entire life. I swam for 12 years competitively. I did triathlons. Nowadays, I like to resistance train. So I figured, nutrition is a good um, um, add-on to the exercise and athletics that I always enjoyed. But as I got closer and closer to graduating with my dietetics degree, I started to realize that I really enjoyed teaching because I was tutoring for the Nutrition Honor Society at Rutgers. So through my tutoring efforts, I realized that I really enjoyed conveying information, breaking it down, trying to boil it down to its essence so that you can convey it to somebody who doesn't have as much of an understanding of the material. And from then on, I sort of reoriented myself and recalibrated my future goals so that I could uh, go for my PhD with the intentions of teaching at a smaller school that has a heavy teaching focus, which Rowan does. So I'm lucky to say that I identified it at the right time, and I'm doing exactly what I had set out to do. But that initial motivator was really my recognition that I wanted to teach, particularly at the college level.
Very cool. I really appreciate how you've highlighted the fact that oftentimes we go into something thinking we're going in one direction or we know what our plan is, but that can change and depending on what our experiences are. I think that's something really good to hear. So
Yeah.
your research was in horses, primarily here at Rutgers, but often what we learn about in horses has implications for human exercise and or health. So why is it that we can often apply what we learn in equine studies to human athletes?
Yeah, so horses are interesting for a whole host of reasons, and I imagine if we have a lot of equestrians who may watch this, and I think it's probably obvious to them why horses are interesting and important. There's a few reasons from the research side of things that I find horses to be even more interesting. First, it's their athleticism. I mean, every horse for thousands of years now has been bred for either labor or sport. So they're highly muscular, they're highly athletic. They have this enormous capacity to do physical work. So that in and of itself makes them a really interesting and really great model to investigate the impacts of exercise. Obviously, there are some differences between horses and humans, but even with those differences, whatever they might be, you can always learn from those differences as well. Um, Another interesting aspect about horses that can apply to humans is the adaptations that occur with exercise and training are very similar between horses and humans. So if you're trying to investigate certain aspects of the health impacts or performance impacts of training and nutrition, horses are a really good model to do that if you don't have access to a willing human population. And probably the third and fourth reasons that I would bring up is that horses, very similar to humans, are the only other mammal that really sweats to thermoregulate. So when you exercise or anybody goes out and exercises, particularly on days like today where it might be hot and humid, you'll notice that you'll immediately start to sweat, and that's a mechanism to cool your body off. Horses do the same thing. So a lot of those adaptive responses that help you to regulate your body temperature also occur in the horse. And that fourth reason that I brought up was that horses age similar to humans. So a year for us is about 3 for horses. So we can actually investigate horses that are quite similar in age to a human population, which may not be so easy or so representative if you're using other organisms such as yeast or fruit flies or mice, where their lifespans are quite abbreviated compared to humans. However, a lot of researchers try to compare them despite those huge differences. So horses offer a wealth of opportunity in terms of understanding and comparing what happens with exercise and nutrition in them, and then applying it to humans.
Very cool. And so based on my understanding, much of your research focused on training and detraining. You briefly mentioned training in your last response. So can you explain a bit more, what are these two phases and why are we interested in them?
Yeah, so training refers to the repeated bouts of structured exercise. So hopefully people are becoming more interested in physical activity. So any structured physical activity, we would call that exercise, whether it's aerobic training, you're going out and running or cycling, or resistance training, and doing that repetitively over time, we call that training. And with that training, there are adaptive responses that occur. And through those adaptive responses that make you more resistant to fatigue and stronger and faster and more agile and resilient to the stresses of exercise over time, those not only help to improve performance, but they also can have huge impacts on health, which is why exercise is typically recommended as preventative, if not, hopefully not treatment, but can help to reduce your risk for diseases, or maybe even treat certain diseases such as diabetes, obesity, things of those nature. So that's one reason why you might want to investigate training, in addition to just how does training impact your performance over time. So a lot of my research was looking more at the impacts of training and how that training impacts things like aerobic capacity, your body composition, or horse's body composition, as well as what's going on within the muscle and the pathways and the metabolic processes that might account for the changes in performance and benefits to health with training. Detraining is the exact opposite. So once you achieve a trained state where you are highly fit and can engage in repetitive activity for longer and longer periods of time with greater and greater effort, the removal of that stimulus also has impacts on your body's ability to perform and health. So one of the other interests that I sought to examine with my dissertation work was what happens to things like aerobic capacity and body composition and running performance in horses with prolonged detraining, or the removal of the exercise stimulus. And one of the interesting findings that I saw in my project was that even though we removed exercise, structured physical activity from these horses for about 5 months, not only did they maintain their aerobic capacity, but their running performance wasn't hindered at all. That is quite different to humans, actually. So this is sort of a novel difference between organisms that is interesting, because if we can identify what is going on in a horse that allows them to maintain that capacity, maybe we can apply that to the human. So this would be an instance where the differences inform not so much what happens in a human, but what happens in the horse, that we might be able to develop novel strategies to then apply it to the human. So those are just two aspects of my research that I accomplished using the horse at Rutgers.
Very cool. So you've mentioned in brief some of those changes that you found. Can you talk a little bit in more detail about some of those changes, especially on the training side of things? So you mentioned you looked at things like body composition, aerobic capacity, some of these traits. So what exactly were those changes that you saw then?
So as far as aerobic capacity and body composition, with the training, we saw a nice robust increase in their aerobic capacity. So just as you would see in horses or any other training study with humans, their ability to consume oxygen and exercise for a longer period of time at higher intensities was improved. So that's pretty standard response. But some of the novel, interesting findings with training, and all of that was really independent of any changes in body composition. Their body composition didn't change all that much with the 12 weeks of intense training that we had them carry out. But the novel, interesting findings that we saw were present in the muscle. So I actually got to look at changes within skeletal muscle that occurred surrounding a bout of exercise before we started training them, but then after the training period. So really looking at how does training impact fitness from a molecular and cellular perspective. So one of the findings was revolves around a metabolic pathway that's involved with protein metabolism and how we respond to stressful stimuli. And in, just as you would expect, in the untrained state, this stress response pathway was actually activated in response to the stressful exercise stimulus. However, with exercise training, that stressful response was not activated in the trained state. So most people are familiar with the term conditioning, and that's exactly what we showed. These stress responses are actually conditioned over time so that your muscle cells actually have a greater resilience to exercise. That was one novel finding that we saw. And then the other one was looking at global metabolic signatures, kind of like, you can almost think of it as like a fingerprint. And just like your fingerprint is unique to you, there's a fingerprint that is characteristic of your muscle when it is untrained, and then how that responds to a bout of exercise. So we were able to characterize that signature, that fingerprint in the untrained state, and then saw how it adapted over time with training status and a bout of exercise in that trained state. And we saw that most of the metabolic signature revolved around adaptations involved with protein metabolism and lipid metabolism. And these findings were in agreement with some other studies that looked at, rather than metabolic signatures, but genomic and transcriptional signatures. So if you kind of think of down the line from your genes and then the RNA and then the proteins that are made, the ultimate outcomes are the metabolites that are produced. So our metabolic signatures are in pretty close agreement with some of the other molecular transcriptional genomic changes that have been shown to occur with exercise training in the horse. So this is just one more layer of evidence to suggest that as you get more and more fit, you rely more and more on fat as a fuel source, and that's a pretty standard and well-known finding across the literature in humans for sure. But now it's starting to be well recognized in the horse as well.
Very cool. Those are some fascinating findings. I've also been told that you had mares and geldings, so males and females, in your study. Did you see any gender differences?
Yeah, so we did have mares and geldings. We had 8 horses total in my study, and it was an even split between the mares and geldings. And they were all pretty close in age as well. So we wanted horses that were somewhat representative of racing aged horses, although they might be slightly older than what's characteristic actually on the track, but pretty close. And even though we had an even split between the sexes, we did run some statistics to pull out to see if there were any differences between mares and geldings. And there weren't any that were strongly statistically significant. And that goes for those stress protein pathways that I had mentioned, as well as those metabolic signatures, although there was a slight tendency to be some sex differences between mares and geldings in terms of how they use fat following training. Which in the human literature, there is some evidence to suggest that men and women do use fat differently, typically during exercise and then following exercise. My study wasn't designed to really capture those differences. So I would imagine perhaps with a different study design, we could pull out maybe stronger changes between them, but with the design that we had and the small number of horses only using 8, it's hard to really say whether or not those differences, while they were trending to be significant, whether or not they were actually representative of true differences or not. So I'm hesitant to say that we saw distinct differences between mares and geldings, but there's some evidence to suggest that maybe there is, but I can't really confirm.
So you've referenced a little bit as you've discussed how your results compare to findings in humans. So can you elaborate on that a little bit and kind of address what does this tell us about exercise in general?
Yes, so just like humans, horses, they adapt to exercise in a number of ways. Number one, they increase their aerobic capacity. That's characteristic of humans. And probably number 2 is that you rely more on fat as a fuel source in the trained state. So one of the bigger findings that we saw in the horses with those fingerprints that I mentioned earlier is that it looks like they were taking up more fat into the muscle cells and then using it to a greater extent following exercise, which is quite characteristic of humans as well. And you can probably even think of this just if you ever go to the gym or you follow elite athletes, you can see that people that are more physically fit, they tend to have a leaner phenotype, probably because in part they're able to use some of that fat that they have in their body. So as you become more fit, you tend to be really good at using a wider variety of fuels, particularly the lipid that you store in your body. So horses and humans are quite similar in that regard. Some other changes just from a muscle perspective are When you train, depending on the stimulus, if it's more power, the fiber types that comprise your muscle tissue, they will they will sort of transition into fiber types that will allow you to produce more power. And if you're somebody that trains more endurance and aerobically, the fiber types that make up your muscle will transition into fibers that allow you to burn fuels more efficiently and to get more oxygen to those cells. So horses and humans are quite similar in that regard as well. And then something that wasn't part of my research, but was some of Dr. Ken McKeever's early work, was looking at how the cardiovascular system and renal systems respond to exercise training, and the implications with regard to thermoregulation. And in humans, when you exercise train, you actually expand what's called your plasma volume, or your vasculature and the fluid that makes it up. It actually increases in volume, and that allows you to effectively become a better sweater so that you can thermoregulate more efficiently. Horses, just like humans, also show a similar response. It's called the hypervolemic response to training. So there are a number of ways that humans and horses respond to exercise and training in a similar fashion. And those go all the way down to muscle, and how muscle alters its fuel selection and its fiber types to produce power, become more aerobically fit, as well as the vasculature and the thermoregulatory mechanisms that help you to delay fatigue while you're exercising.
So on a more personal level, have your research findings or anything you've read in the literature changed how you approach exercise in your own life?
Not so much in terms of how I've changed the way that I exercise or view exercise. I would say that a lot of the findings certainly confirm findings that we've seen in humans and other models. But I will note that this idea of exercise viewed as a minor stressor that in small doses makes you more resilient, i.e. more fit to that stress over time, the idea of exercise conditioning. I've started to view that more as being applicable to other situations in life. So actually more from a philosophical level, I find this idea, it's called hormesis, where you have small doses of things that are otherwise considered toxic or harmful. If you have them in the right dose, in the right amounts, not only do they not cause harm, but they actually promote resilience. And that's exactly what exercise is. Those stress pathways that I referred to in the beginning, they're activated in the untrained state, but over time they become habituated, showing that the cells become more resilient, or muscle becomes more resilient, or the whole body becomes more resilient. And that's actually quite applicable to other fields of study as well. Human psychology, cognitive behavioral therapy follows the same reasoning. Rather than sheltering yourself from harmful thoughts, you actually face them. And over time, you become more resilient to those. If you think of no gravity and going up into outer space and bone metabolism, if you don't have gravity to interact with your bones and cause stress on the body, what happens when astronauts come back from outer space? They don't emerge from their space capsule and walk nice and heroically off of the spaceship, but rather they have to be carried off the spaceship, or else they might break their bones in their legs. So this idea of exposing yourself to novel, stressful stimuli to promote resilience over time, I find to just be a fascinating idea, and it's been known for hundreds of years. Most people know this as what doesn't kill you makes you stronger, or the dose makes the poison. And I have evidence for that from a molecular exercise perspective. But the more that I read in other fields, I realize how applicable this is I mean, your immune system as well. You know, obviously there's a pandemic going on right now, but if you just think of allergies and things of that nature, there's really interesting research with exposing yourself to things that people would um, like peanuts at a young age. If you take individuals that are more susceptible to getting peanut allergies, and you split those children up into two groups, and you give one group a snack that has like a peanut dusting on it and the other group nothing, and follow them up over time, you'll realize that the group that got the peanut coated snack as kids actually had much lower rates of peanut allergies than their group that was given the traditional recommendation of not consuming peanuts because it might cause them to have the allergy. So this idea of these small stressors and responding over time to create greater resilience is I'm starting to think of that at a more philosophical and broadly applicable level than just exercise.
A fascinating insight.
Mm.
And so you talked a little bit in that response about starting exposure early with your peanut example. So does the same thing apply in exercise? Since our listeners are mainly youth, how important is it for them to get out and exercise and start those exercise patterns early in life?
Yeah, that's a great question, and I would say um, the earlier the better. Humans evolved really to be active individuals. So being active and uh, um, um, exposing yourself to those I use the word stressor, but that's what exercise is. It's a stressful stimulus on your body, but it helps you develop your bone and your musculature system and your cardiovascular system. So it is well understood that exercise is beneficial for health, but also overall well-being, mentally and cognitively as well. So for kids that are thinking about going outside and being active, I would say absolutely go for that. Um, um, uh, it can only be beneficial to your health as long as you're doing it obviously in a safe and responsible manner. But yeah, I started competing swimming when I was 6 years old. So I was already racing at a competitive level when I was 6. I had swimming lessons before that. So I was quite active from a young age. I played soccer and baseball and basketball and all a host of different sports. No real contact sports, which is a different story. But just general aerobic physical fitness and exposing your body to those ground reaction forces, the forces that are sent through your body as your feet hit the ground. Yes, they maybe from a biomechanical and stress level, they might sound damaging, but actually they promote health and resilience over time. So there's this idea that the less and less active we become, and the more inactive we are, we develop these sort of mismatched diseases, these diseases that they don't really impact our ability as a species to reproduce over time, but they do impact our health later on down the road. So most individuals that are in their older years, they tend to get a lot of diseases such as cancers and osteoporosis and obesity and diabetes. And these are all diseases that probably have beginnings in inactivity. So I would say find something that you enjoy doing and just try to get better at it and try and find some enjoyment in it. When I was younger, it was swimming for me, but as I got older, I realized, hey, I really like weightlifting. So that's what I do now. So the key idea is to find something that you enjoy, and try and get good at it.
It's really great advice. So I think that's all the questions I had for you. Is there anything I haven't asked you that you really wanted to share today?
Nothing that I can think of off the top of my head. Just thank you again for having me here, and hopefully I was able to give some decent advice or stimulate some thoughts in individuals and think a little bit more about the horse, um, outside of maybe just a wonderful animal that we get to ride and race, but can also be used to offer some insights into how to be a healthier and more active human.
Well, thank you very much for sharing your time with us today. I very much appreciate it.
Absolutely. My pleasure.